Dennis Dimick is the executive editor for Environment at National Geographic magazine. He leads their coverage of energy, climate, and sustainability issues and has published or guided coverage on a wide range of environmental topics. Dennis orchestrates the agenda and moderating sessions for the annual Aspen Environment Forum, which is co-sponsored by National Geographic and the Aspen Institute, and also presents many slideshow lectures on the collision between energy, climate, and the environment, essentially like our blue footprint. He has recently addressed audiences at England's University of Nottingham, the MIT Earth System Initiative, Yale Institute of Biospheric Studies, the World Bank's International Finance Corporation, National Geographic Live, World Watch Institute, National Science Foundation, American Council on Renewable Energy, American Renewable Energy Day, and Carnegie Institute of Washington. Dennis grew up on a hay and sheep farm in Willamette Valley near Portland, Oregon. But he came to Madison, interesting enough, just 90 miles west of here, to get his graduate degree in agriculture. Before joining National Geographic, he worked at newspapers in Oregon, Washington, at the Courier-Journal of Louisville, Kentucky. He joins us from Arlington, Virginia. Please welcome Dennis Dimick.
Well, actually, that water issue was published the month before I joined the National Geographic Society in September of 1980, so I can take no credit nor blame for it. But I think there's also something interesting I want to tell you about how I ended up there, because the state of Wisconsin actually was critical in my being able to end up working there 30 years ago. I was working as an editor at the Courier-Journal in Louisville, Kentucky in April of 1980 and received a phone call from somebody in Washington saying, "We have a job opening for an editor, would you please apply?" And I was going, "Oh, okay, fine." So I went up and interviewed and then never heard anything for months, and I had never even met the person who was going to be my boss. And then I got a phone call saying, "We've hired you." And I said, "Oh, really?" And later I found out that the guy who did the hiring, his name was Bill Allen, he later served as editor of the magazine for 10 years, said, well, I hired the guy with a graduate degree. And that made all the difference. It was a master's degree in agricultural journalism at the University of Wisconsin-Madison. I used to read the pig prices on WHA every day from 12:30 to 1. I did a farm radio show. But that year in Madison was critical to my life and has made all the difference. And I would say that it's now the Department of Life Sciences Communication. And I think just in terms of coverage and communicating about these environmental issues, the state, just as we're supposed to be able to do that well and effectively now, I can say the state of Wisconsin 3 decades ago had a critical role in being able to set me on this path that I would like to talk to you about today, which is the story of water. Is that type coming up white, I hope? Okay. And it's the story of this issue, but it's also the story, I want to walk through it with you. There's 3 key ideas I would like to do with you today. Why a water issue? What were the reasons behind that? I'll talk a bit about the issue itself, the sort of the key issues that we tried to address, and also where do we go with water as civilizations, as individuals, and how the work that all of you are doing is actually going to be so critical in helping the world get through this water bottleneck. The backstory for this really becomes, for more than a decade, I've been involved in helping organize and orchestrate and come up with ideas for coverage of stories about the planet. In September of 2004, we published 70-odd pages in 3 stories on climate change based on scientific reports. It was the largest project we'd published on one idea since the original coverage of the eruption of Mount St. Helens in 1981. We also did the cover story on melting ice in June '07 was the most popular story with our readers in 5 years. These stories are very popular. But also what we've been trying to do also is to try to help people understand that the climate conundrum is tied to the energy question. And if you want to deal with the physics of it, more CO2, more planetary heating, more change in the climate. And that's basically as to how fast that goes. What are the solutions we need to apply to what degree and how fast? Those aren't necessarily scientific questions. They may well be policy and economic questions and how societies choose to make decisions. But what we have been trying to do is to try to explain these issues for people so that they can become better informed citizens. And so here is why we ended up doing the water issue. It all starts here with the blue planet, and it is solar powered and always has been. And as you look here at this algae, this is storing current sunlight. This is photosynthesis. This is what grows our crops. It's exactly the same thing that it's been doing for the eons. But then what has happened, though, is this stuff, a black rock, is coal. All that is old plants that were growing over millions of years, and that those plants were then turned into coal over millions of years. And what we did is we, about 300 years ago, discovered it and came to realize that this stuff was very powerful. It's like somebody discovering a savings account in a vault in the basement, and we're digging it up and we're burning it as fast as we can. And I stand here before you today because of the power of that energy. We are here today because of the power of that energy. It's like we all have 10,000 servants at our behest every day through the embedded energy in the coal, oil, and gas that has made our modern civilization what it is today. But what we're doing is we're cutting down forests, so, like here in the Amazon, so that we can do things like grow more grain, more soybeans, to grow more livestock, to feed to more affluent people like those who are in China who want to live like us. All of these are on track, though. When you look at this, you take a look and you see that world population, since when I was born in 51, it was 2.5 billion. We're currently closing in on 7, and at current rates, we're going to go somewhere around 9 billion by mid-century. Well, as was shown earlier today, the relationship between the number of people on the planet and the energy that we use is related. About 80% of the energy globally comes from those fossil sources that we so depend upon to make our world what it is now. So you see two rising curves. You see rising populations, you see rising carbon dioxide. Well, what that CO2 does is actually change the chemistry of the atmosphere. And what it's doing is it's like when you're cold at night, you put more blankets on your bed. And CO2 actually, if we didn't have it, we would freeze. The temperature of the Earth without the CO2 would be something like minus 18 degrees centigrade. So CO2 itself makes Earth habitable, and we need it. But like water itself, not enough, and you die of thirst, too much you drown, and it's the same thing with CO2. There's a balance point. And historically, that amount has always been less than 300 parts per million. Well, we're moving north of that and have been ever since the beginning of the Industrial Revolution. So what happens is that stuff goes up, you get more of it in the atmosphere, and actually the radiant energy, that it's not the visible energy that we see from the sun, it's the radiant energy reflected back off the planet that goes back up and bonds with that CO2. And so you get more CO2, you get more heat trapped near the Earth. And there's a fingerprint that shows it doesn't go above a certain elevation. So there's a relationship. It's a physics question. Well, so what are the impacts? Well, we're seeing changes in temperatures around the world. This map done by Goddard Institute of Space Studies for us that we published 3 years ago, the orange, that's almost 4 degrees Fahrenheit average increase in temperatures over a 30-year period. The red at the top is the polar regions. That's almost 8 degrees Fahrenheit. So what we're seeing, yes, we are seeing cooling in some areas, but on average, in total, the overall environment is warming up. Well, okay, so what's happening? It's actually doing things like, as Ed said, it's changing the nature of ice on the land. This is melting glaciers in Greenland, water coming off the land, going into the ocean basins. We're seeing glaciers and mountains. This is the South Cascade Mountain Glacier, 72 years difference. This is Chacaltaya in Bolivia at 17,500 feet elevation. In 94 was the world's highest elevation ski area. 11 years later, there is no more ice. As it relates to water, though, more specifically, we're beginning to see a change in seasons. This map was produced by the USDA in 1990. My ag roots are showing here, but this is actually showing growing seasons. If you're a gardener, you're always wondering, well, when's the last freeze date in the spring so I can go out and plant? And how long is my growing season before the freeze kills my flowers? So let's take a dot here and drop it on Milwaukee. That's where we are now. And look at all the blue around. That's a growing zone. And then we're going to move forward 16 years. This area, like much of North America, is losing its cold, is losing its winter. Winters are not as cold or as long or as severe as they used to be. It has implications if you try to go to a bank to get money to run a ski area at low elevations or low latitudes. If you like to fish on Lake Mendota in Madison, it means the number of days of ice you will have available has declined dramatically. This actually came from a University of Wisconsin study in 2000. And what it showed was that lake systems all over the northern hemisphere are losing their ice. The number of days per year is declining. So when in Madison, it used to be almost 4 months of ice per year in the winter, it's now less than 3. So you see a signal globally. You're not going to see this stuff in your backyard if you're just looking in your backyard necessarily. You have to aggregate these behaviors that are happening globally. But what's happening also, we're seeing changes in the behavior of call it the water cycle, the hydrologic cycle. We're seeing more dry, we're seeing more wet. And we see that here in this map that NASA did for us. And what you see, the green is wetter areas, and what you see in brown are drier areas. Wet areas are getting wetter, dry areas are getting drier. And we're seeing more extreme behavior in the way the weather's behaving. So we're seeing more intense rain. Here, the Mississippi River flood in '93 was said to be a once in 500-year flood event. Well, in Cedar Rapids in '08, this was also said to be a once in 500-year flood event. I heard a scientist from St. Louis say a couple of years ago on the radio, it seems like we're seeing these once in 500-year flood events every 7 or 8 years. So we're seeing not wetter, but we're also seeing drier. Here we have the Murray-Darling Basin in Australia, which used to produce about 20 million tons of rice per year and put it on the global grain market. They've run out of water. It's like the Dust Bowl was here. When you take 20 million tons of rice off the global grain market because you don't have water, it has an impact on global food supply. But if it's not drought or flood, it's also extreme snow. This was my front yard in February. I think the point that needs to be made about the extreme storms that hit the Northeast this year is that it was not very cold. The average temperature at my house was about 31 degrees. And if it had been 33 degrees, nobody would have said, oh, global warming has gone away. But in fact, it was very warm. What we just saw were extreme amounts of precipitation coming down, just like we are seeing around increasingly these severe short-term weather events, lots of rain coming in very short periods of time. But we're also seeing, because the freezing levels in places like the coastal mountains of the West, the Sierras and the Cascades are rising, we're seeing shorter snow seasons. We're seeing smaller snowpacks in the western mountains. We're seeing more precipitation in the winter coming as rain instead of snow. And so you have reservoirs that aren't big enough out there to hold all that. But another intriguing situation that's changing the nature of the water cycle in the West are dust storms. And we saw this last year in Arizona and New Mexico. This storm in New Mexico was dumping dust all over the San Juans in Colorado. And what does dark colors do? It's like you don't want to go out in the summer wearing a dark t-shirt, but that's what the dust was doing to the snow. And it darkens the snow and causes it to melt earlier. So you're getting actually earlier runoff in your streams in mountains around the West. And it ends up leaving reservoirs not full. You get earlier peaks in your runoff. But also because of changes in the temperature and the precipitation in the West, we're also seeing things like beetle kill-offs. We're seeing all over the forests of the West. This is directly tied to water. Cooler, wetter summers give way to warmer, drier summers, which give beetles the opportunity to breed 2 cycles in a summer instead of 1. So that it's a tough battle for the trees to go against when you have a much more productive insect. Consequently, you get more fires, you get longer fire seasons, and that's all a result of warming temperatures, a desiccation of the landscape because of loss of temperature. So in essence, what you're seeing is a water cycle disruption. In some places, it's like, this is like, remember the movie when the guy built the baseball field in Iowa and hoped that if you build it, maybe they will come? Same thing here. This is on the Jordan River. They built a dam hoping that it would rain. Yet on the other side of the coin, I mean, you have more volatility like here in China. Once again, it's this extreme short-term events. You have them here. But then you have about half the world's population that depends upon rain-fed agriculture, subsistence agriculture, and if they don't have the infrastructure, they don't have the irrigation systems, the water storage, and all the capital things that are necessary to store, capture, and move water around and create buffers, then they are vulnerable as the water cycle shifts. And we already saw that in 2008. When we saw crop failures, we saw rises in energy prices, and we saw crop prices go up partly because, for example, the 20 million tons of rice that wasn't available from Australia. There were so many knock-on effects that year. But what we do know is this. We're rapidly approaching 7 billion people, and the amount of water that we need is going to keep going up. So we're in the situation of rising demand and constant supply. And perhaps one of the more eloquent statements that summarizes this for me is from Sandra Postel, who's now a National Geographic Water Fellow. She was affiliated with the World Watch Institute for many years. She heads the Global Water Policy Project. And though freshwater supply is renewable, it is also finite. The quantity available today is the same that was available when civilizations first arose thousands of years ago. And so the amount of water that should be allotted to each person has declined steadily with time. Well, if you have lots of oil and you have lots of money, what you can do if you live in Dubai is that you just use that energy to convert salt water into fresh water like here. But that's the exception, and this is more the rule, that you have most of the people on the planet where there is the least water. And increasingly we see this sort of conundrum. We're facing this increasing gap like here, the billboard in China advertising nirvana, when the reality is right behind. And we do try to forestall these kinds of things. For example, this is in the Punjab of India, so what will we do if we don't have surface water? Well, we'll just drill more wells. And that's what they have been doing to try to maintain food production, and is actually the case that's been happening in many areas of the United States. If you go down the Ogallala Aquifer through the Great Plains, we're drawing down fossil water. That it's like it's sort of delaying some inevitable questions that we have to come to terms with about water supply. And so if you look here, this satellite map just published last year, the red spot, that's showing where the loss of all the groundwater is in India, because they've drawn it down, because they didn't have the surface water and they need to eat. So here you come. This is it. If you want to see, this is Environmental Water Scarcity by Basin, published by World Resources Institute. This is why we did an issue on water. It's a critical issue for the planet. And if one wants to get specific, what we have here is the Aral Sea, which once was the world's 4th largest lake. This is from 2000. Just 9 years later, this is what remains. The lake was depleted, as was said earlier, by upstream diversions for irrigation. So we come to an issue on water. That's why we did this issue on water, and it's not an issue that's going to go away. So in one sense, if you want people to do something, the first thing you have to do is help them understand and help inform them about these things so that they can be better informed and make decisions, just like all of you are trying to do in your work. We're all working together for that cause. And to do that, what we try to do is basically lay out So what is fresh water? It's like, gee whiz, I mean, we're a water planet. How come we're talking about having so little? So we walk through an appreciation of it, and we talk about the rivers and the beautiful waterfalls, but we also talk about the fact that here you have this water planet where 97.5% of it is seawater, and you can't drink it. And that's where most of it is. And there's 2.5% down there in the corner, but that's not all we get to use. And if you then take that 2.5% and you keep going, drill further down, see the little red sliver? That's what, 0.3% of the 2.5%. That's what we're dealing with when you start looking at things like the amount of water in the Great Lakes. Yeah, 20% of the world's freshwater supply right there. When you look at the great rivers on the land, like the Columbia, the Mississippi, the Yellow, the Nile, that's where we get most of the water. Yes, we do get well water, but most of this is coming from freshwater recharge. Well, how much water is that? 0.7 of all the water on the planet. That's what we're talking about in the lakes, in the rivers, in the swamps on the planet. And that's what we draw upon for the most part to sustain human civilization, to grow our food. And if you look here, what you see is most of the use of water on the planet by human civilization is for agriculture. A fifth for industry, and that's what we use in our house, 8%. That's what all of us in the aggregate use. So if one were also wanting to say, gosh, how could we do a better job? Obviously, it looks like a low-hanging fruit here is how can you do a better job with water and agriculture, because that's where you can make your biggest return on your investment. But beyond that, this is not oil, it's us. We're water, water is us, and so the relationship between water and us, it's different than energy. There are alternatives, as was been said, but there is no substitute for water because it's all around us. We began life in it, and we need it every day. And so what we did was then we tried to say, okay, in this issue, let's try to play that to help people understand that the relationship with water is not just utilitarian. It's sacred, it's ritual, it's refreshing. It's the thing that we always love to do to rejuvenate ourselves. I go to the pool every day if I can. It's so lovely to do that. But it's also part of our rituals. This in Japan, here in Istanbul, here in India, in Cambodia, and in France at Lourdes, and here in Maine. So our relationship to water transcends need. It's rejuvenating, and it's also us. But also there are critical issues, and we tried to address those. We did a story on the Tibetan Plateau, the third pole, the one area outside of the two poles where the largest aggregation of ice occurs. The nature of the ice in the Himalayan Plateau is changing. We tried to get to that to help people understand the significance of the role of ice and rivers and water for a third of humanity on the planet. So here at the headwaters of the Yellow River, I hope you guys are seeing it. My monitor down there doesn't look very good. But here in India, soon to be the world's most populous country at 1.5 billion, already short of water, like here in Delhi. Take a step back. This is the Himalayan Plateau, the Tibetan Plateau, the Himalayas across the south. Take a further step back, and here it is. You have 5 or 6 major rivers. It's the water tower of Asia, feeding, nurturing a third of humanity. And the nature of the place is changing. If you look here, these are David Brashears in the Asia Society was involved in a rephotographic project of these glaciers. What you see here is in 1921, you see the Rongbuk Glacier near Everest, and then you see in 2008, the glaciers are disappearing. There are archives of water that actually even out stream flows in dry years. And many areas depend upon the stands on the western side of Asia, Actually, they are the highest per capita user of water in the world for doing things like growing commodity agricultural crops. But downstream in India, already we're seeing changes in the weather patterns, changes in stream flow, changes in monsoon. This whole area is one of the most fascinating areas, and we will be doing another story on Bangladesh next year. The story of water slavery to me is perhaps one of the most compelling of all the ones we did. This is the story, The Burden of Thirst, the tale told of the women and children who spend their whole lives walking, hauling, carrying water because they don't have any way to get it otherwise. 1 in 6 on the planet don't have safe, clean water. And it's these women in Kenya and other Eastern African countries who spend their whole life climbing mountains, digging holes by the side of the road, pitching jerry cans up. This is what their life is like. And if there were one place other than here, if there were one area where actually small investments could make a huge difference in the lives of people, it's in this question of trying to help people get clean water in their lives instead of having to haul it 5 miles if you had a tap by your door. I know it sounds alien to us, but for millions, it's a big deal. And so if this is her water and the cows drink the same water and stand by the same pond, this is why you end up with 5 million people or so annually dying from bad water, a lot of them children. The question of trying to deal with these illnesses is prevalent in these countries, but also if you're trying to just get by. And so what we did, and also this story, we didn't just deal on the supply of water. The water conundrum is also, well, sanitation, because it's like, what do you do with the water once you use it? Or how do you prevent the water system itself from being fouled because of things like waste? 40% of us don't have sanitation, I mean, worldwide. Just solving the clean water and the sanitation problem would go a very long way towards improving human health. And so that's what we tried to get at here, this whole idea that if we can do small things can make a big difference. This is a latrine. They never had one before. It makes all the difference in the world for these people. But also it's like educating people about water is really necessary if you want to help change their behavior. We can be technological and be more efficient, but also helping people understand how they can do a better job with the water they have. Same thing with educating people about sanitation. And so we tried to tell the story about it's heroines like this woman who came in to tell this, to help explain to children what are the best ways to do your daily functions, and also talking about what happens when NGOs can help people take control of their own lives, build a water supply system that comes to the village, and then the whole idea that you keep it going. I think the big question with these water supply systems in places that don't have them is not that the water supply system went in, but is it still working 10 years later? That's the real success story. If you can get that, that makes all the difference. But the freshwater species story, actually what we're trying to do also is like, well, yes, water for people, but also water for nature. And you have to think about the needs of nature because without it, there won't be much for us. And so what we tried to do here was we looked at rivers in the southeast United States. These scientists are looking for endangered freshwater mussels. And so the tale really here was just to try to show examples of animals that depend upon fresh water too here in the Missouri River. This turtle, he perhaps became the most favored portrait of the whole issue, very, very popular. This is a large salamander, pallid sturgeon, and the frog. We're just saying it's not just us who need this stuff. The animals also do too. The story of California water to me was intriguing as a Westerner. It's like we have created an amazing hydraulic society that for most parts doesn't have any business being there. Ed, sorry, but you put 30 million people in this place and then you create all these fabulous water transfer systems and keep your fingers crossed. And this was Lake Shasta, the largest reservoir in the state of California. This would have been last fall. So, the question is, you have to do, your resource isn't what used to be, so you better work real hard at making the most of what you have. And it's a really fascinating story of taking nature and putting it to your use. Here, water coming across from the Colorado. The story of Colorado water is fascinating because it's like snowflakes that fall on Mount Shasta in the far north in the Cascades, and snow that falls on the western slope of the Rockies just west of Denver, all come to California to keep it going. It is it's an amazing story of taking water from far places and building a civilization and producing some of the most fertile agricultural land, like these laser-leveled lands in the Imperial Valley. But also, the Owens Valley is our very own Aral Sea. Okay? And Mulholland took that and took the water out and sent it to this, built these big pipes and pumps and sent it to LA. And look, LA is like, that used to be what was called the LA River. It is now a aqueduct or a channelized stream. There's not enough left to even get to the sea. And last, I think one story that we tried to do that was really intriguing was this story of, well, if you have two civilizations that don't get along very well, the Jordan River, Israel and its neighbors, the struggle between a declining resource, it may be that the water will be the one thing that keeps them together and gives them the opportunity to try to find some common ground. It's drying there. There's less water. This is said to be the place along the Jordan River where Jesus was baptized. Some places we have lots, other places we don't have much. A lot of people live this way, and it causes a lot of stress. But they're trying to work through it. Unlike here where we have lots of water, they're trying to deal with not much at all. And the telling sign is that the Dead Sea itself, which is at the low end of the river, is going down. Laurent talked about the virtual water idea, and I want to show this to you, and I'll give you the URL for the website, so if you haven't seen it. But this poster, to me, was one of the most intriguing things we did, other than mapping the world's rivers in a new way, but it was this idea of embedded water. The water that's in the things that we use every day, or and what I'll do, for example, top right, the big bubble, 2,900 gallons of water to produce one pair of jeans. And if you zoom in, and what you see is, you can see what, top left there, that's a pound of beef, 1,857 gallons of water. If you go to the right, halfway down, you see that a pound of corn takes 108 gallons. So it gets back to that thing about eating on how high in the food chain we eat. If we eat lower on the food chain, we actually become more water efficient. So in the end, I think one idea, and this applies especially to everybody who's in the area of water resources management. 2 years ago, the journal Science published this piece. It was called Stationarity is Dead. And it's this idea that the behavior of hydrologic systems, rivers, lakes, streams, the behavior in the past is going to determine the behavior in the future. Well, based on the changes in the climate and the temperature and the rainfall, it's not a smart strategy to continue to rely on that, because there's too many things happening now that would say that's not a reliable model. Take here Nashville, for example, in early May. It was lost in the headlines. By then, the oil spill had just taken over page one. But it was on the day of the Kentucky Derby, Saturday, May 2nd, 6.5 inches of rain fell in Nashville. The following day, another 6.5 inches of rain fell in Nashville. Unprecedented, never been seen before. This is the hotel at the Grand Ole Opry. So what we have, though, is that, so essentially we've built these systems that we rely upon and hope that they will be consistent and reliable. But if you look here at Lake Powell, what you came to see is that there's a signal there. There's a sign. It's showing you. There's a bathtub ring. It's saying, I'm not full. And we need to take heed of those. I mean, already the talk is that Lake Mead will be at Deadpool, and that means no water out. Las Vegas is trying to solve the problem near term by putting in a water pipe lower in the reservoir to solve the water problem. Well, but still, if you don't have water coming in. So it requires us to be innovative and ingenious and to be efficient and to figure out ways to make the most of what we have, and whether it means recycling the water in our life or finding ways to keep from evaporating the water that we're storing, or even rethinking our expectations about what we think should be. All of these things are open for us, I think, and they're useful for us to say, well, what can we do that we haven't thought about before? And it really is this question about short-term versus long-term thinking. So a couple of examples not well reported on the long term. This was a study that was published by Stanford 2 weeks ago on the number of extremely hot seasons per decade. And what you see, this is projecting forward, and you look from 2010, 2020, 2030, what you're seeing is an increased frequency of hot seasons. That has an impact on water availability, on whether you're growing crops, all of these things. And you have west of the 100th meridian, you got 60 million people living there. So all these things. And even if you look up in the upper Midwest, you see in 20 years, we're going to be seeing hotter summers. That changes the hydrologic cycle. Just last Friday, the National Research Council, the National Academy of Sciences released this report. Nobody's reported on this thing. It's the question of the impacts of additional degrees of warming on things like local rainfall, stream flow, and crop yields. And it was very precise, and it was the very first time that we've seen these kinds of precision. You can see 10% less rain for each additional degree in the southwest U.S. You're going to see declines in stream flow, and by extension, lower crop yields. This is where the climate and water question are intimately tied. So we can do a better job with the water that we have, but we also have to confront the energy situation. So in one sense, it's from crisis does come opportunity. And so we're in this place now where we depend on things like a black rock to keep the lights on, but also we need to keep in mind that civilization itself depended upon the sun for most of its time, contemporary sunlight, to build the civilization that we live on today. And I think beyond the question of whether these resources are going to run out, I think perhaps one of the most intriguing questions for us all is, can we take that gift of those fossil fuels that are available for us now, and they are still in reasonably good supply in most cases, can we take those fuels and use them to build a bridge to a sustainable future, so that we can get off of them and come back to contemporary sunlight? So we're in this position of looking down at the earth, and we see these houses in Arizona, a swimming pool in every yard, and we can ask, what is the difference between need and want, and what do we really need? And it's useful to look back history-wise, and here's Chaco Canyon, a civilization that was built and disappeared because the water disappeared. They didn't know that the water was going to disappear. We're in a position now where we see the signs, we can act wisely and prepare. And so the future is coming more quickly than we think. And these kinds of choices are on our table. And I would say to all of you that the work that you're doing here is so important, because you're going to be doing the kinds of things that are going to help all of us do a better job with the water that we have, and not only here, but around the world, helping people solve the water problem. And I thank you very much.